GCSE required practical 10A. This is infrared radiation, or the emission of infrared radiation. So we're going to use the Leslie's cube, and this is a metal cube which is painted with different colours on the side. So we've got a shiny aluminium foil, we've got one with a copper side, and we've got a matte black finish and a shiny black finish here. And the idea is that you fill this with hot water, freshly boiled water, and then you measure the emission of infrared radiation from each surface. Okay. Now what we've got set up here is a data logger with an infrared power meter, which is just here. This is the only solution to this experiment that we're really happy with at all. The exam board suggests that you might want to use an infrared thermometer which measures temperature. Now, whilst that works in the same way as this, it gives you a measurement of temperature, whereas this instrument gives you a measurement of, well, it gives you the intensity of the radiation, so the power per square metre. And really, that's a much more valid measurement to be taking. If one was to actually touch the side of each of these faces with a thermometer, you would find that it is exactly the same temperature, because the material is just conducting very efficiently and it would have nothing whatsoever to do with radiation. So this version of the experiment we feel is much more true to the proper physics. So what do you need to do? Well, you need to take a measurement of each surface, and this is the matte black surface, and it's sitting there at 151 watts per square metre. Very carefully, you then rotate this very hot block, trying to make sure that the distance between the surface and the infrared sensor is approximately the same. And here we have the copper one, and we've got a reading of 17 watts per square metre. And then we'll rotate it again to the shiny aluminium foil surface. Again, we'll try and get the distance approximately what we had before. It's hovering between 15 and 17. I'm going to make that 16 for the shiny silver. And for the shiny black surface, let's rotate back round again. And here we have about 148 watts per square metre. So a significant difference between the different surfaces and the emitted infrared radiation.